I'm Crystal Portocarrero. I am the product manager of advanced threat here at Juniper Networks. And today I'm just going to talk a little bit about AI-driven risk profiling, which is our new integration between security and the MIST, which is really exciting. As far as the agenda is going to cover some of the problems, right, that facing security, but not only just security problems, but some of the problems that ripple out to the rest of the business, whether it's the network, the Wi-Fi, right, and everything in between because of security. Talk a little bit about threat detection and some of the methodologies behind that, and of course, then we'll end with a quick demo. So as far as challenges go, this is nothing new, I think, to anybody who's been doing security for a long time. There's always that balancing act of risk mitigation and business agility. The best way to secure your network is to not have one at all. That's not really a reality, I think, for most of us, right? Having connectivity and providing that connectivity for legitimate services and users and devices is crucial to keeping everything up and running. And then, of course, you have all of these buzzwords like working from home, zero trust, shifts to the cloud. All these things kind of propel us forward, but there's legacy systems that often can hold us back. You think about things like the Equifax breach. That was due to a vulnerability in the automated consumer interview system that was built in the 1970s. Right? You have all these devices and things that are happening, right? At the end of the day, any type of downtime is costly for any reason, whether that's the Wi-Fi, the WAN, a system outage, or a security event. And so we spend, all of this time kind of and money on keeping the lights on, but we're running with old incandescent bulbs instead of changing them out for LEDs. And then, of course, you couple that, I think, with some of the more common challenges in the security realm, a lack of cybersecurity professionals, things like alert fatigue. We've craved more and more visibility for so many years, but now we get so much data thrown at us that it's way too much. There's too many things going on, too many alerts popping up, and too many individual data points that it becomes really difficult to kind of find the signal in the noise. And it's like, a very serious problem. So you look back at something like the Target breach, there were over 1,500 alerts on the day of that breach. It was just, everybody was ignoring them because it was too much. And so it's just something that a lot of companies, both large and small, fail at because it's a really difficult task and kind of the numbers are stacked against us. So what do you do, right? I think everybody can kind of relate to that feeling of being overwhelmed and struggling just to keep up. Well, you have these digital technologies that sit at kind of the heart of almost every industry today. The automation that we have behind it, the greater connectivity has really revolutionized the world, our economic and cultural institutions, but it's also brought in a lot of cyber attacks and the number of those cyber attacks, the sophistication of them. So how do you actually kind of deal with that? And I think one of the only ways to really do it is to look at the network, to look at the applications running over the network and cybersecurity all as a whole, right? That's, I think, the only real way to start combating, right, these compounding issues. And so with threat detection, we've gotten really good at detection. The first model for an intrusion detection system was published by Dorothy Dunning in 1986. So we've been doing this type of detection for a really long time, signature-based detections. Of course, we've gotten better at it. We've gotten faster at it. We can handle much larger amounts of traffic through these systems. But what about all those unknown, and new threats? Like Juniper Threat Labs, we publish new signatures for our IPS twice a week. But for anything that gets through that initial kind of detection layer, this is where behavior data becomes really important. Eventually, something that's on the network that's malicious will take a bad action. And so maybe Dawn and I were burglars from a past life together. Because if you take the idea of, you're sitting listening to a really boring presentation, so you're staring out the window and you see somebody walking down the street and they peer into a car and then they bust the window, they open the door, they get in, they fiddle around under the steering column, and eventually they drive away. What just happened? And you likely watch somebody's car just get stolen. And even though breaking the car window, to get in, that initial kind of breach, that's a pretty, easy way to get in. You could be a little bit more sophisticated, They could have used a Slim Jim, right, and gone through the window and unlocked the door. And maybe there's, the sensors you can grab for key fobs, right? And you can redirect that signal and unlock the car door. So there's better ways to get into the car nowadays than just breaking the window. But at the end of the day, that action of breaking into the car stays the same. And you see the kind of same thing happening in the malware development scene, where developers are really focused on creating new features, right? Finding new vectors and ways to get in and improving on what they've done, right? Or they don't improve as much on some of the older techniques. So while there's a lot of reuse going on, and the window being broken or the car getting broken into, it's going to look a little bit different. The exact procedures you took to get into the car, right, they've changed slightly, but the end reaction is the same. And
as
you
long
also
as
see the
the
same
stone works against the window, they will use it. Yeah.
Yeah. Sometimes, the easiest way is just to, take a brick, right, throw it through the window. It's quick and dirty and easy. And you see the same thing happening, right, in the malware scene, especially when you get into things like malware as a service. You don't have to be a sophisticated hacker anymore. You just need a credit card. You can go out, you can buy a botnet or an entire ransomware campaign. It comes with a nice dashboard, tells you how many devices, right, you've infected, how much money maybe you've made in Bitcoin. A lot of these come with 24/7 support. And for that to really work, of course, they're reusing, right, the same malware. They're not creating new, unique malware for every individual customer. That's not a really good business model for them. So that reuse actually helps us defending the network. But the other thing you have to do is you have to start collecting all of this data from different points within the network, right? North-south traffic coming from the internet, as well as traffic in between, right? In the kind of east-west scenario. And because there's so much coming in, that's where ML really comes into machine learning, because you have to start to leverage that. And you need not just the bad behavior by itself, you need to start looking for groups of behaviors and using statistical analysis to find both those direct and indirect indicators. Because going back to that scenario with the car that was stolen, well, what if you had, say, a Ring camera or a Nest, right? Everybody's got those nowadays. And you were to go back and look at the footage from 2 hours ago, and you saw the same person get out of that car. Now, do you still think that you witnessed, a car being stolen? Or do you think you just saw somebody who's had a really bad day? They were running late for a meeting or to pick up their kids at school, and they just had to bash in the window with the nearest rock to get in, because as they stood up, their keys fell in their pocket, fell underneath the gas pedal, and they had to get going. So you need all of those indicators to be able to get kind of an accurate idea of what's actually happening. And again, we talk about, I've used the words ML, use the word AI later on in the presentation too. I try not to use them too often because, they are a means to an end. They are not the end solution themselves. They are just technologies that help us leverage and deal with certain issues. You talk about artificial intelligence, it's about experience, about taking that kind of user and operational experiences, abstracting them, learning from them, and then providing some amounts of kind of automatic adaptation at a faster pace than humans can alone. But it's important that you understand the problem you're trying to solve using these tools. Not everything is a perfect use for AI or for ML, and you don't necessarily have to be a data scientist or an engineer to cut through that hype that's there. You see all your old security tools now fortified with AI and ML, just like you fortify your cereal with vitamins A and D. It's just important to think about what problem are you really trying to solve with these tools. While we can do threat detection really well with ATP Cloud using machine learning, one of the important things is how few false positives, we have to alleviate that alert fatigue. And then we talk about MIST and Marvis and some of the artificial intelligence there. It's about taking all of those insights, in that user experience and just making it quicker, to get to the end result. How do you start to pool all of these things together so that all parties involved in running the network and keeping the lights on work together? And so I think everybody knows, what a breach looks like from the perspective of a security professional. We have all these cool security tools. We can break down the malicious behaviors of malware. You can provide process trees and network calls. You can even use tools like Ghidra, and completely reverse engineer that malware. You can look for signs of post-infection. Is something calling out to a C2 server? And if it's encrypted, we can still, right, look into that encrypted, right, just into the SSL handshake data and get an idea of whether or not that is a connection to a botnet or not. And so there's all these things we can do, but what does that breach look like to other people, right? And so I started thinking about this a while ago. They said there was this one of the last trips I took before, well, we could, so before we had to stop traveling, was to Amsterdam. And none of the, I had a really great meeting with the partners and everything there, but the story here doesn't really start until after work. It was meeting a guy at a cocktail bar. And he comes in, he was the owner of a company that manufactures cabinets. And as I talked to him, I mentioned that I happened to do security, and he said, oh my God, you know what? I just had this ransomware event. And tell me kind of all about it. It was, horrendous, and that they had some of their networking guys and pretty much anybody that could do anything running around the building, literally yanking cables out because it shut down their manufacturing floor, right? The workstations that ran the machinery that made the cabinets completely got hosed. And so there's a loss of money in the manufacturing time. There's a loss in time for the overtime to fix, right, and go through and mitigate a lot of this, to get all of the workstations back up and running. So there's a lot of loss there, and it's also just the feeling of helplessness. And then also, what does that look like not only from the CEO's perspective, but from the network admin's perspective, right? For them, it's a loss of uptime. It's a loss of sleep. I mean, a lot of them were working overtime to get the network back up and running. And they were able to do it in 3 days, but that's 3 days of working around the clock. And so, that's one of the things to always keep in mind is not only how an incident affects the security side of things, but also how does it affect everything else, right, in the company for the network admins, the server admins, right, everybody else. And so that's really where AI-driven risk profiling comes in, is it takes all of the security intelligence, all of the cool security, right, machine learning things that we do on the ATP Cloud, and allows it to kind of converge with the network. Because at the end of the day, it's not just about security, it's about the experience for the end users and also the administrators as well. So we're able to take all that information, publish it to MIST, make it all actionable so you get a faster and easier way to mitigate an incident with kind of more surgical precision. And it also provides you a lot of context, right? Not just the context in the security sense, like, how malicious is this piece of malware? Is it a Bitcoin miner? Yeah, that's bad, but you can wait till after lunch to deal with it. Or is it a piece of ransomware that's going to rip through the network and kind of tear things apart very quickly? So you get that type of intelligence, but you also get the context to know how best to take action. Is it a person or is it an IoT device? Is it moving? Is it stationary? Is it quickly spreading throughout the network? It's like you have all these little green dots right now that show all of the kind of devices on the network, but if all of a sudden they start turning red and they're spreading really quickly, this is something you might want to jump on immediately. And then of course being able to locate that device and mitigate it and as close to real time as possible. So no more running around randomly yanking out cables and then trying to figure it out after the fact. It just provides a better experience for everybody overall. And I like to think about it, in the sense of the self-driving car. So there's the AI engine that is the self-driving car, right? It's Marvis for us, right? It's the network itself. That's what's stopping, what's going, what's turning left and right, takes you from home to work, stops off to get coffee in between. It knows how to route around traffic. And all of that is great. But you would not trust that self-driving car if it didn't know when to stop properly because somebody ran out in front of it, or a stoplight, right, all of a sudden changed from yellow to red. Or another car, right, they ran a stop sign. How do you trust that if it doesn't know when to stop properly? And so that's kind of how the ATP Cloud functions with MIST, is it's the sensor on that car that says, hey, please stop, right? While MIST is really the AI engine, right, and the network itself that goes, okay, let's slow down, let's remove this malicious device in this event and kind of clear it up and deal with it now, and then keep moving.
The Mist AI was very much around wireless, but on your earlier slide, you were talking about wired and wireless. So have you extended the Mist AI to go into wireless? And is it really just looking at the end connections, or is it actually coming back into the network now?
Mist has been extended to the WAN side of things and also to the wireless side through our switching capabilities. And I know why it started out very much centered around the Wi-Fi. We've extended that to our switches and now also to the WAN side with the SRX firewall. Before running through the demo, what I want to talk about just a little bit beforehand is the topology itself. So how this is all set up, we have an iPad that is connected through a Mist access point to the internet through an SRX firewall. The iPad has then downloaded some malware. As that malware went through the firewall sent it off to the ATP Cloud, where the malware itself was detected, using all of our machine learning goodness. And then this is the kind of the exciting part is when that malware's been detected, that host then goes onto what we call the infected host feed. It says, hey, here's all of the devices in your network you should be aware of because they've downloaded, they have some kind of infection on them. So that still goes to the firewall, like it always has through SecIntel. But now we're also sending all of that threat information to Mist. So from one place, you get all of the information you need, and then we can deal with that on the networking side. Right now, we're looking at the ATP UI. What you have on here is the infected host list. So you can see here all the different devices that have been scanned. You can see things like, malware downloads versus CNC hits coming from SecIntel, whether the investigation is open. And you also get then a threat level, And this is part of the risk detailing information. And so we can see here that host, which is the iPad, at 192.168.1.10. We'll click on that and you can see here, Tuan has been busy downloading malware. And the MAC address on that device is Delta Foxtrot 17. You can always see this, because it's kind of the device view. But if you go into the individual event, we can get some idea of, again, what happened, What is this malware? You can see here it's a Trojan. It was downloaded from, they came through the demo SRX 320. You can see the URL that it was downloaded from. You get all the behavior analysis, What happened when we put it in the sandbox? Why do we think, What behaviors did it exhibit that make us think it was bad? But here's the exciting part where we go to Mist. We look at network and then security, and we'll take a look at this client list. And all of that threat information now has been populated from the ATP Cloud over to Mist. You can see, it was DW Hall's iPad here, Delta Foxtrot 17, so same MAC address, same IP address as before. No smoke and mirrors. If you click on that, you can see, you get a high level idea of all the different security events that have happened. So you see that same event, again, just high level details. You also have the option of, clicking on that link to go directly to the ATP portal to see it again. But here we're just going to go to the map view. We see where this device is in space. Okay, so we need to go deal with it. We know where to find one now. But before we even go and deal with, kind of the incident response and forensics part, let's go ahead and just ban the device from the network. So just in case this doesn't spread anywhere else. Now that the device has been banned, we should see that happen on the network. We're to go into the wireless LAN settings real quick. Take a look at the security demo network. And you can see here that we have the prevent ban clients from associating. So since that is selected, anything that has been banned, should not be able to associate. So let's go back to the client list. And we can see now this device has been banned. You notice that it no longer has an IP address. It's not able to connect to the DHCP server, so it no longer gets an IP. And once we go and do the forensic investigation, clean up that device, and it's ready to go again, you can go ahead and click unban, and then it'll be allowed back on the network. And that's it.
I have a question.
Yep.
As far as I can tell, this is an iPad, and the malware that you have is a Windows malware. So banning an iPad because of a Windows malware being found doesn't make that much sense, because it will not do anything on that device. Is there any thing in this where it will tell you, okay, this is malware, this is not good, but it's not harmful to this device?
The EXE was done just as an example so we could trigger the malware event for the malware. I think when Medora covers Security Director Insights, there we're able to ingest events from like endpoint protection systems. And there we'll be able to give you the context that, yes, there was a download. Yes, someone tried to execute, but then your endpoint stopped it, right? So there's no need to do anything. And ATP Cloud or the ATP solution or the ATP on-prem with SDI is able to lower the risk because we know that, okay, yes, they downloaded malware, but the endpoint protection system stopped it. So hopefully that answered your question. We can provide context for that with some of the additional tools covered later in the presentation.
Okay, thank you.
Even though this is not necessarily part of the demo for ATP Cloud, there is actually an ATP solution that has this built into the evaluation of the threat. So ATP on premises, for example, would be able to say that, oh, there is a mismatch between the two, therefore I'm going to reduce it a little bit. But we have to be careful about these things because sometimes you're not quite sure whether this is going to a VM running somewhere, for example.
And that's part of the integration with just between the ATP Cloud and Mist right now. That's why there's still, you have to click the ban option because you do get, this is an exe and then you can see it's an iPad. So while it's better to have a tool that just kind of does all of that for you, you also can, kind of create that context because that's part of why it's so, I think, important to integrate the security, right, as a sensor as part of the network. So you get all of that meaningful information over right into everyone's hands. So you can kind of stop the ripple effect, but you can also just, again, make choices based off of all the context you have, and you have it at least all in one place here.
How long can you store this information? For the last 30 days, or is there a limitation?
Yeah, so I'll take this one. There are two types of things that we store. By default, a lot of the information based on our end user license agreement is stored for 2 months. But certain types of information are actually removed immediately, especially if they're not deemed as relevant to any kind of threat. So the clean stuff, for example, gets removed right away. The malicious stuff by default gets kept for 2 months. That's accessible to you as a customer.